2 days. So today we're just going to work on graphs that have translations, or it could have a vertical or a horizontal stretch or compression. Tomorrow we're going to get into the horizontal shifts, which are called phase shifts. For today, we're just going to focus on producing graphs of sine and cosine, identifying the amplitude and period of the function. And you may or may not remember doing this in Algebra 2 Honors, or you probably covered this in FST, right? Okay. All right, so the functions sine and cosine have a period of 2 pi. Now, when we say sine and cosine, we just mean the sine of x and the cosine of x. What I had you do yesterday is you graph the sine and the cosine, and we didn't focus on all of these values, like the root 3 over 2 or the root 2 over 2. What was really nice about our graphs yesterday? Well, what was nice about them?
They were like 1 every 90 degrees.
Yeah, exactly. Every 90 degrees, so it was 1, 0, -1, 0. And that's because what did we use to find those? How did you guys find your values? What did you have to use? Your unit circle. Okay, so on the unit circle, the ones that we want to focus on are going to be at 0, pi over 2, pi, and 3 pi over 2. Okay, so here I'm at 0, 1. Here I'm at, 1, 0. Here I'm at 0, 1. Here I'm at -1, 0. And 0, -1. So this was my 0, my pi over 2, my pi, 3 pi over 2, and then back at 2 pi. Now notice at 0 and 2 pi, I'm at the same exact point. That's because that is a full period, and when you have a full period, you are going to repeat the last value. So the sine and the cosine functions repeat their values in the length of 2 pi. And that's because it starts and ends on the same point. Now we're going to look at just the graphs of sine and cosine. And I've circled a couple of special points on here. What special points did I circle? Yeah, so here this point would be at 0, 0. Okay, this point is at pi over 2, 1, where it hits the maximum value. Okay, at pi, I'm at 0. At 3 pi over 2, it hits the minimum value. And then at 2 pi, I'm back at 0. So when you're graphing, you can either graph with a pattern or you can graph with a table. So when you're thinking of your sine, we should know that at 0, your sine value is always going to be what? 0. And again, you'd know that from your unit circle, right? At 0, it's 1, 0, and all your points are cosine sine, right? Okay, so then this would be your cosine, 0 would be your sine. All right, so it's going to start at 0. If one full period is 2 pi, then at 2 pi, it's going to hit 0 again. Now, for the sine function, it also hits 0 where? At pi. So halfway in between these, you're going to hit the same point. Now, because we're going to have shifts, it's not always going to be 0. So it's more the pattern that I'm trying to show you here. Okay? Now, you will hit the max halfway in between these. See how pi is halfway between 0 and 2 pi? It's always going to occur, the special points are halfway. So between 0 and pi is what? Pi over 2. Okay, so at pi over 2, it's going to hit its maximum value, which is what? 1. Halfway in between pi and 2 pi is 3 pi over 2, and that's going to hit its minimum value. And sorry, because I think my maximum looks higher than my minimum. Okay, but this is going to be your general shape. and this is for the sine function. Okay, that's your general shape. For the cosine, you have some similarities. So at 0, where does the cosine function start? It starts at 1. Okay, which means if the period is 2 pi, at 2 pi, where do I have to be? I have to be at the maximum again. I have to be at 1. Now let's look and see what happens in between. In between your cosine, here's your max, here's your max, but here it hits what? The min. That's halfway in between. What is the minimum? I should make this nicer here. Okay, so your min is -1, and that's going to be at pi. Okay, so for cosine, it starts at the max, ends at the max. Halfway in between is the min, and then halfway in between the min and the max is what? Is pi over 2, and what happens at pi over 2? It crosses the axis, so it's at 0. At 3 pi over 2, it crosses at 0. Okay, so I kind of think of this like a longhorn. I think of it like this. Looks like a little longhorn to me. Okay, and then your sine does one wave up and one wave down. Okay, so those are your general shapes. Make sure that they're curved. Okay, so no straight edges. All right, so one way that you can find how to graph is to follow your pattern. How many of you, just by show of hands, feel really comfortable just graphing by the pattern? Like if I gave you the problems, you could probably just do them all based on that. All right, so I am going to give you all the problems here. And I already gave you your homework. Okay, so if you finish these, make sure you check in up here to make sure you did it correctly how I want you to do it. But then you can start working on your homework in between those. So the first thing we're going to talk about before I give you the problems is the sine and the cosine curves. And you have two equations for those. The first one is y equals a sine of kx. The second one is y equals a cosine of kx. And then it tells us that the amplitude is the absolute value of a. If your amplitude is the absolute value of a, that means it's always going to be what? It's always going to be a positive value if it's the absolute value, right? So your amplitude is always positive. Okay, and then your period is going to be 2 pi over k. Do you guys remember that from last year? So I want you to take a look and see where your k value is. Okay, in each of these. How would you explain that to somebody? Where's your k value? What do you think? Okay, yeah, it's in front of the x, right? Okay, so here's your k value. Okay, now k has to be greater than 0 because if it wasn't, if it was 0, then you'd have 0. Okay, and then that'll be true for both your sine and your cosine. All right, an appropriate interval on which to graph is 1 complete period. So that would be 0 to 2 pi over k, which remember 2 pi over k is the equation for the period. So they're just saying, oh, an appropriate window to graph would be from 0 to your period. We're actually going to be spanning all of our graphs. Okay, so when you graph, you have to span the entire graph. Okay, so when you graph, you have to do what? I didn't feel all of you on that one. Okay, so when you graph, you have to do what? Okay, so you're going to have to make sure you do the whole thing, okay, to get full credit. Now, to find a good scale for your graph, you can always take the period and divide by 4. Okay, that's nice. It divides it up into quarters. Can you think about maybe why that would be nice? Thinking of the unit circle. So remember how earlier Mitch was saying how we went by pi over 2? Pi over 2 is a quarter of the circle. Okay, so we'll work through that together. So like I said, this is going to take some practice, and that's fine. When you graph, you're going to have to label your units, and there is a special way I want you to label your units. Okay, so before some of you who can work ahead, I want you to just pay attention to how we're labeling, and then feel free to go on from there, okay? So for A, we have y equals 5 plus the cosine of x. For B, we have f of x equals 3 plus 3 sine of x. Okay, for A, we're going to have y equals 1/2 cosine of 4x. And then the last one is y equals -3 sine of pi times x. Okay, so we're going to start part A with the fill in the blank. So the graph of cosine is shifted. So this is what you did yesterday on your packet. If you had the +5, what did that mean? Yeah, it's going where?
Up.
It's going up. How many units? 5. Okay, so this is being shifted 5 units up. And then we're going to find our period. So to do that, we're going to use 2 pi over k. So your period is going to be 2 pi over, well, the k value's in front of x. If you don't see a number in front of x, what is it? It's 1. Okay, so then this is just going to be 2 pi.
Are we labeling it just those 4 values? But like the x values?
We'll do a little more than that. I'll show you. Okay, so once you have your period, if it is one of your 4 values that we talked about on the unit circle, the 0, pi over 2, pi, 3 pi over 2, or 2 pi, then you can just go ahead and you can use 2 pi is where your graph's going to go. All right, so for this one, that's what we're going to do. So this is how I want you to label it. At 2 pi, I'm going to put that right here. I want you to label it on the bottom. That way I can clearly see where your points are, and you can still do your curve. Okay, then it just makes it easier for me to read. How many units did I use to go to 2 pi? If you count how many units, how many did I go? 8. So that means if I go 4, 4 is half of 8, which means halfway would be at pi. Well, if 4 is pi, then 2 is going to be half of that, which is pi over 2. So every 2 units, I'm going pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, just like how we count on our unit circle. And then we also have this part, which we have to label as negative pi over 2. At the very least, I want you to label every other one. If you wanted to label every one, you could, but you don't have to. Technically, every one space on here is equivalent to what value? Pi over 4, because see how this is a half? Half of a half is 4, 1/4. So pi over 4. So really it is going by pi over 4. That's not something you necessarily have to label. All right, now there are two ways to do this. You can do your pattern or you can do a chart. Okay, so you can do a pattern or you can do a chart. I'm going to show you the pattern way first, and a lot of this is going to be me talking you through it. Okay, so when you're labeling your y, let's figure out where our highest point is going to be. That way we have to know if we're going to change the scale or not. Okay, so Kenny, do you think you could tell me how you know what the highest value is?
Well, it starts at 1, so 5 plus 1 is 6.
Okay, so
6.
the maximum for just our cosine is 1. So if you do 1 plus 5, you're going to get what? 6. Do I have 6 units on my y? Nope. Okay, so I have to go by what? 2. So this is how I want you to label that. So just at the top of your graph, you're just going to write y scale by 2's. And then wherever your highest point is and your lowest point, I just want you to label that on the y-axis. And you can label that actually on the y-axis. Okay, so let's do 0 first. Now again, you don't have to make the chart. If you get stuck though, the chart is what can save you and set you free. As long as you know how to plug in and evaluate with your unit circle, you could always find where your point is on your graph. Okay, so this is how you can rationalize through it. If you plugged in 0, this is what you would be doing. If I plugged in 0 into my function, I would have 5 plus the cosine of 0. What's the cosine of 0? 1. So I'd have 5 plus 1, which is going to be 6. Okay, so at 0, I know I'm at 6. Do you have any questions on that part? To plug in 0 and get out 6? You also know it's going to be your highest point. So 2, 4, 6. So remember I said just label where that highest point is there, which is 6. You can always label more, just at the very least I want you to label that. And then we'll find the lowest point. Now remember, this repeats every period. So what's my period for this? 2 pi. So if it repeats every 2 pi, at 2 pi, I'm going to be back at 6. Okay, now let's look at the cosine. So remember I showed you this earlier. This was your cosine. So this is your max. This was your max. Halfway in between, what happened? What happened? Hit the minimum, right? Halfway in between the two max, you hit your min. Okay, so we can find our minimum. What's the lowest cosine value it hits? Yeah. So in cosine, just cosine, what's the lowest value it hits? It hits -1, right? So if you do -1 plus 5, what are you going to get? 4. Okay, so halfway in between, I'm going to be at 4. And that is going to be your lowest value. So I'll just have you label that. Okay, now I'm going to put those on my chart. So at 2 pi, I was at 6. If you aren't sure how we were getting this point, think of it as plugging in pi. If you plug in pi, 5 plus the cosine of pi, what's the point at pi? At pi, what's your point on the unit circle? -1, 0. Okay, so cosine is x. So this is 5 plus -1. 5 plus -1 is going to be 4. So that's how I know this is going to be 4. Okay, now again, according to the pattern, if you look at your pattern, halfway in between, it hits at halfway. See how this is 1 to -1, and it hits at 0? And that's halfway in between. So these are both halfways. Okay, so halfway, halfway. Okay, and then what's half of the distance between 6 and 4? What's the distance between 6 and 4? 2. What's half of that? 1. So then I would just go 1 unit down in between them, which would be where? 5. And that will be both of them. Okay, now you could also do 5 plus the cosine of pi over 2 to find this. So at pi over 2, you're at the point 0, 1, which means your cosine is 0. 5 plus 0 is going to be 5. So that's how you could fill in your chart. Okay, now we have to keep going with our pattern. So they, like I said, they're going to keep repeating themselves. So at negative pi over 2, now you're going to be going down to 5. And then you can just put the arrow to show me where it's going to go next. And then we're going to connect this with a curve. Okay, so this is just a little tighter because we're going by 2's. And you can just show me that with the arrow. Okay, and then we're going to go to part B. So for part B, the graph of sine is shifted blank. Okay, so Blake, where is this shifted?
3 units up.
Yes, okay, so it's 3 units up. And that comes from this 3. Okay, and then Charlie, can you tell me what this 3 means? What does that do to your graph?
That will vertically stretch it by 3.
Good, okay, so this is a vertical stretch. So we're going to say and is vertically stretched. By a factor of 3. Okay, so when you're vertically stretching, you're taking the graph and you're literally pulling it vertically. Okay, so it would be longer and narrower than your original graph. Again, we're going to have to find our period, and then we're also going to want to know what our max and our min is. Do you guys remember that from yesterday? You guys did some vertical stretches, but you also did it in Algebra 2. Okay, where if it's on the outside, it would be a vertical stretch. So from what you did yesterday, if you know what the sine of x is, how could you find what 3 plus 3 sine of x is? What could you do to the y value of that? What did you guys do yesterday on your chart? Yep, so you can multiply by 3, and then you'd have to do what? Good, so you can multiply the y-coordinate of sine of x by 3, then you can add 3. Okay, and then your period, you're still going to find that the same way. So 2 pi over k. Again, the k value's in front of x. You don't see a number, which means it's going to be 1. So then your period is going to be 2 pi. All right, so I'm actually going to label my graph just how I did before. So I have my 2 pi, and again, we're labeling at the bottom. 2 units is pi over 2. 2 more would be 1 pi. And this would be 3 pi over 2, 2 pi, and negative pi over 2. Okay, and if you need to, please feel free to make your chart. If you don't need to, you don't have to make it. This is just to help you. Okay, so we're always going to start by finding what happens at 0. So the sine at 0 is what? 0. So if I multiply that by 3, I get 0. And then if I add 3, I get 3. Is is that going to be my highest value? No, because what is my highest value? My highest value of the regular sign is what? 1. So then I can multiply by 3 and then add 3 to find out what it is. So 1 times 3 is 3. 3 plus 3 is 6. So that means my y scale has to be by what? 2's. Okay, so y scale by 2's. And then again, just make sure that you have labeled where you are on the y-axis, and then your highest point and your lowest point, unless your lowest point is 0, and then you don't have to label it there. Okay, so at 0, I'm at 3. So if I'm going 2, 4, 6, I'm going to label my 6, and then I'm just going to label where I am here, which is at 3. How do I know where my lowest value is going to be? What's your lowest value on sine of x? -1. So if you do -1 times 3 plus 3, what do you get? 0. So 0 is going to be your lowest point. Okay, so if you're using the pattern, all you have to do is look at the period. The period is 2 pi, which means if at 0 I'm at 3, where am I at 2 pi? 3. Excellent. Good job, Ms. Whipple. You answered your own question. Hey, does this make sense that you're going to end and start at the same place? Okay, so if your period is 2 pi, you're going to be ending at 3. Okay, let's look back at the sign. So when I drew the sign for you, we looked at how you start at 0, you end at 0, and what happened in the middle? What happened in the middle, people? It's at 0 again, right? See how all 3 of these are at the same point? So the start of the period, the end of the period, and halfway of the period. Okay, so for this one, the halfway is pi, and again I'm going to be at 3. Okay, so this would be 3, this would be 3, this would be 3. Now, if you don't have a reflection, the first thing it's going to do is reach its max. Again, that's halfway between these. And then it will reach its min halfway in between the next two. Okay, so your maximum value, you can either reason your way through it like we did. We talked about how 3 times 1 is 3, 3 plus 3 is 6. So we know our highest point is going to be 6. And then we talked about how we know our lowest point is going to be 0. Or you can plug it in. If you plug it in, all you have to do is 3 plus 3 times the sine of pi over 2. Then you think of your unit circle. At pi over 2, I'm at the top of the circle, which is 0, 1. The sine is the y-coordinate. So this is 3 times 1. 3 plus 3 is going to be 6. That's how I know at pi over 2 I'm at 6. If I were to plug in 3 pi over 2, then the sine value at 3 pi over 2, which I can see from my unit circle, is -1. So 3 plus 3 times -1 is 3 minus 3, which is 0. That's how I know this is going to be at 0. And then you're just going to continue with your pattern. So remember, you have to span the whole graph, so I can't leave this blank over here. So will you check yours and maybe just glance at the person next to you to make sure that they did this part? This is going to reach the minimum now. And once you touch it, it's going to go up. Make sure you put your arrow going in the correct position. Okay, so don't write the arrow going down. That's not right, right? It touches it and then it's going to come back up. Okay, and then for example 2, we're going to find the amplitude and the period. So the amplitude we talked about earlier is going to be the absolute value of the number that's in front of the function. So in front of this function is 1/2, my amplitude is 1/2. Okay, Sam, what do you think my amplitude is going to be for B?
Well, it'll probably be 3.
Yep, can you tell me why?
Yeah, because you have to look like this one's weird because it's not right on the working line on the x-axis.
Well,
So
you're just going to use your equation, right?
yeah, and then you just figure out that it's 6 high and divide by 2.
Okay, so your amplitude is always just in front of your sine function. Okay, and the amplitude always has to be what?
It has to be positive value.
Positive, so it's the absolute value. So the absolute value of -3 is going to be 3. Okay, so now we're going to do our period. So our period is 2 pi over k. So for this one, our k value, Ben, what's our k value for this? 4. Okay, and that's because your k value is always in front of x. So 2 pi over 4 reduces to what? Pi over 2, so that's going to be our period, pi over 2. All right, and then let's do the same thing for this one. So it's 2 pi over k. And Caleb, what's our k value for this one?
Pi.
Pi. Okay, so again, our k value is in front of x. Well, what's 2 pi divided by pi? 2. Okay, so then your period is going to be 2. And that is going to change how we're going to set up the graph. Okay, so we're going to do A, and we are going to keep this at 2 pi. So we're going to keep this at the same scale that we have been doing. So here I have pi over 2. Here I have pi. Here I have 3 pi over 2. You're going to find that you use this scale a lot, and that's perfectly fine. Okay, now let's figure out what the highest value is going to be. Okay, so this is cosine, and for the cosine, the highest value is 1. So if I plug in 0 and get 1, 1 times 1/2 is 1/2. So I don't want my graph to be all scrunched up. So I'm actually going to make this 1/2, which would make this 1. So really, each unit on my y-axis is going by what? Yeah, so your y-scale is by 1/4. And again, if you need to do the chart, do the chart. Plug in 0. Okay, you will get 1/2. So at 0, I'm at 1/2. Now, this repeats every period. What is my period? Pi over 2. So it repeats every pi over 2 units. So if this is where I start, and my period is pi over 2, for cosine, I'm also going to end at 1/2. And keep in mind your picture. Okay, so it's going to start at your max, okay, and end at your max, unless of course you had a what? Reflection. Because if you had a reflection, then you'd have your min. Okay, so I'm going to start and end at my max. What happens halfway in between the two maxes? I hit the minimum. Okay, so halfway in between 0 and pi over 2 is what? Pi over 4. So if you weren't sure what the point was, you could always plug in pi over 4. If you plug in pi over 4, we have that the cosine of 4 times pi over 4 times 1/2. What's 4 times pi over 4? Pi. What's the cosine at pi? -1. So 1/2 times -1 is -1/2. So at pi over 4, I hit -1/2. Okay, so again, remember, I just want you to label the highest point and the lowest point. So 1/2 and -1/2. Halfway in between those, it's going to hit the halfway mark. What's halfway between 1/2 and -1/2? 0. Do you guys see how that is a skinnier version of your original? Okay, and then, but we have to do what? Span the whole graph. So I'm just going to keep going, right? It's every pi over 2. How many units makes up pi over 2? 2 units, right? So I can just count 1, 2. That's a pi over 2. 1, 2. That's a pi over 2. 1, 2. Pi over 2. 1, 2. Pi over 2. And then I can keep doing that with every single point. So even the minimum is going to repeat. 1, 2. Here we go. 1, 2. 1, 2. 1, 2. Okay, and then you can even go the other way. So 1, 2. 1, 2. And then you can even do the halfway marks. It's just when you do 1, 2, you'll do 1, 2. Or you can also just put them halfway in between. Okay, so now when you connect them, just make sure you connect them with a curve. And there you go. So now you can see the effects that this has. So a couple things are happening. This is a horizontal what? Compression by a factor of 1/4. Okay, so what that's doing is that is compressing the graph horizontally, so this way. Think of like a spring, like a slinky. It's pushing it together. That's why you have more cycles. And then the 1/2 is compressing it vertically. So then it's getting shorter, and then it's also getting more frequent. Okay. All right, so for the last one, our period is 2. So if I'm trying to do 2 pi without a calculator, that is not happening. So instead of making them go by 2 pi, I'm going to have the period at 2. So if I make this 2, this is my 0. Halfway in between is going to be 1. Halfway of 1 is a half. And this would be 3 over 2, or 1/2. And then here I'd have -1/2. Now I know those do line up with the same pies, but it's okay if they didn't. Okay, you're always just doing, here's your period, half of that. And again, you can think of it as divided by 4. So if you take your period and divide by 4, 2 divided by 4 is 1/2. Okay, we didn't do it for this one because I wanted to show you what that would be. But if you do your period divided by 4, you got 2 pi over 4, which is pi over 2. That's why I labeled these as pi over 2. Okay, and same thing with the one above it. All right, so I'm going by a half. So the first thing I want to find is what happens at where? What have we always been finding first? What happens where? At 0. Okay, so at 0, again, you can plug this in. You have -3 sine of pi times 0. Well, anything times 0 is just going to be 0. So then the sine of 0 is 0, which means at 0, I'm at 0. Where's another 0 going to be? 2, because what's the period? 2, and every period it does what? Repeats itself. Okay, and this is sine. This is sine, so for the sine, halfway in between, it crosses 0 again. Okay, so then halfway in between, it's going to cross 0 again. Now remember I said earlier, if there's no reflection, it goes up first and then down. How do I know this one has a reflection? There's a negative in front. So instead of going up first and then down, what happens? It goes down first and then up. So it reaches its min and then it reaches its max. Okay, so I know that's going to happen at 1/2. So if I do -3 sine of pi times 1/2, pi times 1/2 is just what? Pi over 2. If I think of my unit circle, at pi over 2, the point is 0, 1, which means the sine value is 1. -3 times 1 is -3. So 1, 2, -3. Okay, so I said make sure you label the min and label the max. Where's the max going to be? The max is going to be at 3. So 1, 2, 3. And if your scale is by ones, you don't have to tell me it's by ones. Okay, as long you just have to label those 2 points. If it's anything besides 1, then I want you to label it. Okay, so if it's 1/2 here, what do we think it's going to be at 3 over 2? So sorry, this was at -3, so this one's going to be at +3. Okay, so I'm just going to do this period to show you. See how that looks just like our original sine graph? Okay, so then now we're just going to keep going. So for this, you can just put your arrow, because that's going to be going down. What's going to happen at -1/2? It's going to go up to 3. Don't put your arrow here, because is it going to go past that value? No. What's it going to do next? It's going to start going down again. Okay, so you can put your arrow there. It's not curved nicely, as nicely as I want. Okay, what do you guys think you like better? Do you like the table or the pattern? So you can always use the table if you get stuck. Okay, you can always plug it in and then use the unit circle for where you want to be. Okay, so I gave all of you a graph paper, and your graph paper actually has all of your homework on it. So your homework is just the 3, 5, 7, 10, 14, 21, 22, 23, 24, and 25, and then those are just extra graphs. They're blank. Okay, you don't have your key up on Google Classroom, which means I am going to be doing what tomorrow? Checking your homework. Okay, and then I will put up the key when you guys come to